Good morning, everyone. Good morning, everyone. Myself, Ram Reddy. I am from the Electronics and Communication branch. Today, my topic is about terahertz imagining antenna array. It is from the antenna and wave propagation. Introduction: the terahertz frequency range typically defined between zero point 0.1 terahertz to 10 terahertz. Bridges the gap between microwave and the infrared region of the electromagnetic spectrum. This region, often called the THZ gap, has attracted increasing attention due to its unique ability to penetrate many non-conductive materials such as plastic, clothing, paper, and biological tissues without the harmful ionizing effects of X-rays. Terahertz imagining in the emerging technology that utilizes these frequencies in obtain both structure and spectroscopic information about a sample. It offers great potential for applications in medical diagnostics, security screening, material characterization, and industrial quality control. Head core of the terahertz imaging system lies in the antenna array, which serve as interface between electronic and electromagnetic domains. The antenna array is responsible for generating, directing, and detecting terahertz waves. By using multiple antennas arranged in 1D or 2D configurations, it enables high resolution imagining faster data acquisition and beam steering without mechanical movement. Recent advancements in semiconductor fabrication, photonic integration, and the metamaterials have enabled to development of compact and the efficient. The antenna arrays. The arrays are often integrated with photoconductive emitters and the detectors, forming the foundation of modern THZ time domain and the frequency domain imagining systems. The project overview of terahertz imagining antenna array. The terahertz imagining antenna array project focuses on the design, analysis, and understanding of antenna systems that operate in terahertz frequency of range zero point 0.1 to 10 terahertz. For advanced imagining application, the primary objectives of the project to explore how THZ antenna arrays can be utilized to generate, transmit, and receive terahertz waves for high resolution, non invasive imaging of materials and the biological tissues. In this project, emphasis is placed on understanding in working principles of terahertz imaging systems, the role of antenna arrays in the image formation, and the technological challenges associated with terahertz wave generation. The study involves analyzing different types of antennas suitable for terahertz frequencies, such as dipole, bow tie, slot, and photoconductive antennas, and evaluating their performance in terms of gain, bandwidth, and radiation efficiency. The antenna array serves as a crucial component that enables spatial scanning and beam steering and the parallel image acquisition, significantly enhancing image speed of resolution compared in the signal element systems. Furthermore, the project highlights the integration and the antenna array with THS sources, detectors, and the signal processing units, forming a complete imaging architecture. Through the simulation and the theoretical analysis, the project aims to understand behavior of the electromagnetic waves in the terrestrial region, study suitable antenna designs for efficiency, terahertz, radiation, and the reception, explore image techniques and the reconstruction methods used in the terahertz, examine potential applications in the biomedical consumption and the material testing. Objectives: the The main objectives of this project is analyze the design and the operation, unique properties of the terahertz and the waves within the electromagnetic spectrum to analyze the working principle of the terahertz imagining systems, explores how terahertz waves are used for imagining materials, inception, and the biomedical applications. To design the examine the terahertz antenna arrays, investigate suitable antenna structures such as dipole, bow tie, or slot antennas, and the performance parameters at terahertz frequencies. To understand the integration of antenna arrays in imaging systems, study how multiple antennas elements are configured to enable spatial scanning, beam steering, and enhance image resolution. pre pre prerequisites and requirements prerequisites before undertaking the terahertz imagining antenna array project. A strong foundation in the following areas is required. Understand the underlying concepts, design principles, and system operation effectively. Basic knowledge of electromagnetics, understanding of Maxwell's equation, wave propagation, and electromagnetic spectrum. Familiarity with wave nature, wave matter interactions, and the radiation mechanisms. Antenna and the wave propagation theory, microwave, terahertz engineering, semiconductor physics, and the photonics, signal processing and the image techniques, simulation and the design tools. Basic knowledge of electromagnetics, understandings of Maxwell's equations, wave propagations, and the electromagnetic spectrum. Familiarity with wave matter interactions, of with gain and the bandwidth impedance, radiation pattern, and the polarization. Knowledge of array configurations, beamforming, and the mutual coupling between antenna elements. Microwave and terahertz engineering, basics of the microwave circuits, transmission lines, and the wave guides. Understanding of terahertz frequency generation and the detection techniques. Photoconductive antennas, quantum cascade lasers, semiconductor physics and photonics. Knowledge of semiconductor materials used in the terahertz devices. Understanding of optical to terahertz conversion and photo excitation process. Signal processing and the image techniques. Familiarity with Fourier transforms, time domain analysis, and the image reconstruction method. Basic understanding of the data acquisition systems and image processing algorithm. Simulation and design tools, experience with electromagnetic simulation software such as CST, Microwave Studio, HFS, and COMSOL. Basic programming or data analysis with skills and the MATLAB Python. Hmm, Data analysis, analyzing suits, safety requirements, productive circuits, technical technologies used. Here's the concise technologies used for transition of the product mic. So design, detailed design and the implementation, TMS, called design and the program. Testing and the validation, measure the magnetic field strength using the Gauss meter or the Salt sensor. Verify the testing and the validation is done in the lab. Lab conclusion: the terahertz imaging antenna array project provides a valuable insight into one of the most promising fields in the modern modern electromagnetic and the photonic research. Terahertz radiation, which lies between the microwave and the infrared regions of the spectrum, offers unique advantages such as non-ionizing imaging, high spatial resolution, and material-specific contrast, making it ideal for various applications in biomedical diagnostics, security screening, and the materials characterization. Through this study, the fundamental concepts of the THZ wave propagation, wave generation, transmission, and the detections were explored, along with the design and operation of the antenna arrays that form of the backbone of THZ imaging systems. The project also emphasized how antenna arrays improve imaging speed, enable beam steering, and enhance overall image quality. While DHZ imaging technology still faces challenges such as limited power sources, detector sensitivity, and high system cost. Ongoing advancements in semiconductor materials, nano fabrication, and the metamaterials are steadily overcoming these limitations. In this conclusion, the terahertz imaging antenna array represents a key step toward the development of next generation non-invasive imaging systems that combine electronic and photonic technologies. With continued research and innovation, THZ imaging holds great potential to revolutionize multiple scientific, industrial, and medical fields near future.